Hello students, welcome back. So far in this chapter, we have discussed about the first law of motion, which is also known as the law of inertia. We in that topic discussed about how inertia is related to the mass of an object. So in first law of motion, we studied that it indicates that when an unbalanced external force acts on an object, its velocity changes. Now we would like to study how acceleration of an object depends on the force applied on it and how to measure a force. So let's relate to our day to day life some of the phenomena that we come across in our day to day life. The first one, if you see, the graphics suggest that a person is throwing a stone, and the other graphics suggest that using a catapult we are throwing a stone. Now compare these two situations. In these two situations, what do you expect? In which of the case the impact will be more? The answer is obvious. If we throw a stone using a catapult, that impact will be much more than throwing a stone using a bare hand. Similarly, I will show you some other situation where we can compare how the impact changes with the change of the mass of the object and velocity of the object. So let's watch one such. So here you watch it and tell me what will happen if a shuttle strikes the face or hits the face of a badminton player. So here in this video, a shuttle is hitting the face of a badminton player. Now you can imagine, you all must have played badminton. So you can imagine what will be the impact if the shuttle strikes the face. Now one of our favorite game, that is cricket. You must have played cricket also. So if accidentally the cricket ball hits a batsman or a bowler or even an audience, what can be the impact? Let's watch this video and compare. So here if you can see, the ball is directly hitting the batsman. So now if we compare these two situations, first situation, a shuttle is hitting the badminton player, and here in the second case, a cricket ball is hitting the batsman. What do you think? In which of the case the impact will be more? The answer is, I think, obvious. The cricket ball, if it hits a batsman, the impact will be much more and the damage will be much more and the injury will be very deep. So what is the reason behind it? The shuttle hitting the face and the ball hitting the face or any part of the body, why it will cause more impact? That is because if you compare the shuttle and the cricket ball has a greater mass, and at the same time the cricket ball also moves with a greater velocity. If you compare the velocity of the shuttle and the velocity of the cricket ball is much greater than the shuttle. So what do we conclude here? We conclude that the impact always will be depending upon the mass of the object as well as the velocity at which it is moving. So here there is a certain quantity which can correlate between the mass and the velocity of an object. And what is that? We call it as momentum. So if you clearly look, the impact produced by the objects depends on their mass and velocity. Similarly, if an object is to be accelerated, we know that a greater force is required to give a greater velocity. That means if you want to accelerate a truck and if you want to accelerate a car, both the cases if you see, force is required, but greater force will be required to accelerate a truck. Why is it so? because the mass of a truck as compared to the car will be much more. So, here what we conclude? So, there is a quantity which connects object mass and its velocity, and we call that property as momentum. So, let us have a look at the definition of momentum. How can we define momentum? The momentum P of an object is defined as the product of its mass and velocity, and an expression given is P is equal to mv. Here P indicates the momentum, m indicates the mass of the object, and the v indicates velocity of the object. So, P is equal to mv, that is the product of mass and velocity of the object. And as usual, it is a quantity, it is a vector quantity, and momentum has both magnitude as well as direction. Magnitude means that amount, and direction, the direction of the momentum of that object will be always in the direction in which velocity of the object is. And what is the SI unit of momentum? The SI unit of momentum is given as kilogram meter per second, because mass, the SI unit is kilogram, and velocity meter per second. So, the SI unit of momentum will be kilogram meter per second. So, at this point, let us, this change in the velocity and its relation with the mass was again established by Newton, and he proposed the second law of motion, which is called as Newton's second law of motion. And what does that indicates? Second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of the force. That means, as we saw, in order to change the velocity of an object, a force has to be applied. So, whenever we are applying force, velocity is changing. Velocity is changing means the momentum is changing. Suppose we want to calculate, we know the change in the velocity, and we want to calculate the force, that can be calculated by the rate of change of momentum. So, the rate at which the velocity is changing, at that will indicates the rate of change of the momentum. So, that rate of change of momentum will give us the force exerted. So, that is your second law of motion. So, let us watch a video here in order to understand the second law of motion with a better clarity.
Consider a wooden block weighing 5 kg, a little over 11 pounds. If we were to tie a rope around the block and with one hand pull it across the table with a force of 10 N, the block will accelerate in the direction of the force. Using the equation A is equal to F divided by M, we can calculate the acceleration. In this case, the acceleration would be 2 meters per second square. If we were to pull the rope with both hands, the force will be doubled to 20 N. In this case, the acceleration will also be doubled, 4 meters per second square. This helps us see that acceleration is directly proportional to the force applied. Let's tie an identical wooden block to our original one. The mass, now 10 kg, has been doubled. If we were to again pull with one hand, that is 10 N force, the acceleration will be 1 meter per second square. In other words, twice as much mass will yield half acceleration when force is constant. If we were to again pull with two hands, that is 20 N force, the acceleration will be 2 meters per second square. In other words, twice as much force applied on twice as much mass will yield the same acceleration as pulling half as much mass with half as much force. If a friend joins you in pulling the blocks, but pulls from the other end, the wooden blocks will not move at all. In this case, the net force will be 0. and there will be no acceleration.
So, what we saw in that video? We saw that whenever an external force is applied on an object, the velocity of the object changes. And if we continue to apply the external force, then the velocity keeps on changing. That means that object accelerates. So, applying a force, we accelerate the object. So, let us look at the mathematical formulation of second law of motion, and which is also known as change in the momentum. Now, let us consider that an object of mass m is moving along a straight line with a velocity of u. It is uniformly accelerated to a velocity v in time period t by the application of a constant force F throughout the time t. So, mass of the object is m, initial velocity is u, it has been accelerated to a final velocity of v by applying a force F for a duration of time period t. So, using all these variables, let us formulate the second law of motion. So, what can we do here? As the velocity is changing, so we can find out the initial and final momentum. So, initial momentum let us indicate by P1, which is equal to m into u, that is mass into initial velocity, and the final momentum, that is can be indicated by P2, which will be equal to mass into the final velocity v. Now, the change in the momentum will be directly proportional to the difference between the final momentum and the initial momentum, that is P2 minus P1, and by substituting the value of P2 and P1, we will get that the change of momentum will be directly proportional to mv minus mu, and which is indirectly again proportional to m into v minus u. So, that is the change in the momentum. Now, if we want to calculate the rate at which the momentum is changing, that means we have to divide it by time period. That will give us an expression, that m into v minus u divided by t. So, here we can know that rate of change of momentum is nothing but the force applied. So, the applied force F will be proportional to m into v minus u divided by t. That means, if we want to remove the proportionality, we will introduce a constant, that will be F will be equal to k into m multiplied by v minus u divided by t, which will be equal to k into m into a. Here a is your acceleration, and acceleration will be final velocity minus initial velocity divided by t. So, here we can formulate that force is equal to k into ma, and if you take the value of k as unity, then your force applied will be equal to mass into acceleration. So, what does this mathematical formulation suggest us? That the force applied on an object to change its velocity can be calculated as the product of mass into acceleration. I hope it is clear to all of you. And as we know, force has a unit, that will be your kilogram meter per second to inverse, that means meter per second square. Why meter per second square? Now, here that is the unit of your acceleration, and otherwise as we know that force SI unit is your Newton, given by the symbol N. So, here what we conclude, that the second law of motion gives us a method to measure the force acting on an object as a product of its mass and the acceleration. So, rate of change of momentum is your force, and force can be calculated mathematically, that is by the product of mass into acceleration of the object. So, to understand the second law of motion, let us solve some of the numerical based on this mathematical formulation, so that we can easily understand. So, here is the first numerical problem in front of you. Take a pen and paper, note down it and try to solve. As I read, a constant force acts on an object of mass 5 kg for a duration of 2 seconds. It increases the object velocity from 3 meter per second to 7 meter per second. Find the magnitude of the applied force. So, what are the things given over here? Mass of the object is 5 kg. It has been accelerated under a constant force for a duration of 2 seconds in such a way that the velocity changes from 3 meter per second to 7 meter per second. So, you have to calculate here the magnitude of the applied force. So, how can we solve it? By simple thing, we will apply here the mathematical equation for second law of motion. So, we will solve this numerical in this way. These are the things given. We have to note it first. Initial velocity is equal to 3 meter per second. Final velocity v will be is equal to 7 meter per second. Time period is 2 seconds. Mass is equal to 5 kg. So, here we will apply the formula F will be is equal to mass into final velocity minus initial velocity divided by t. And if we substitute all this value, then the answer we will get is your 10 Newton. So, the force applied was 10 Newton. So, very much clear. Let us solve another numerical so that it will give us more deeper understanding about the second law of motion, which would require a greater force accelerating a 2 kg mass at 5 meter per second square or a 4 kg mass at 2 meter per second square. Two objects are there, one is 2 kg, another one is 4 kg. One we need to accelerate at 5 meter per second square and the other one we need to accelerate at 2 meter per second square. So, the question is which of the object would require a greater amount of force? Simple thing, let us go for solving it. So, try, we can solve this numerical in such a way that the formula that we will use here is force is equal to mass into acceleration. There are two objects are there. So, we will have two different forces. Let us go for the first one. M1 is given 2 kg. A1, that is acceleration of the first body, is 5 meter per second square. Second object mass is M2 given by 4 kg. Acceleration of the second body is given as A2 will be 2 meter per second square. So, you apply the formula F1 will be is equal to M1 A1, which will give us by substituting the value as 10 Newton. F2 will become as M2 into A2, that by substituting the values we will get at 8 Newton. So, F1 is 10 Newton and F2 is 8 Newton. So, if you compare, F1 is greater than F2. Thus, we conclude that accelerating a 2 kg mass at 5 meter per second square would require a greater force, although the second object is heavier. But here, as the rate of acceleration is more and because of that the force required is more. So, we need to apply a greater force in accelerating the object with 2 kg. I hope it is clear to all of you. Now, from second law of motion also we can derive the first law of motion. And how is that possible? If you look at here, force is equal to mass into acceleration. That means again F will be is equal to mass into final velocity minus initial velocity divided by t, or if we multiply time with force, F into t will be is equal to mv minus mu. So, first law of motion indicates the object continues to be in its state of rest or motion until and unless an external force is applied on it. Supposedly, we are not applying any external force. That means force is equal to 0. So, if force is equal to 0, force into time, that value will be 0. So, if you substitute it in that equation given as Ft is equal to mv minus mu, we will get that mv will be is equal to mu. That means the final velocity and the initial velocity both are same. So, as the initial and final velocity is equal, that indicates if the object is in motion, that will continue to be in its uniform motion until and unless an external force is applied on it. External force is 0, so the object will continue to move in its uniform motion, that will not accelerate. So, this is what suggests your first law of motion. Similarly, if the object is at rest, that means initial velocity is 0, so also the final velocity is 0, that means the object will continue to be at rest. So, from second law of motion also we can derive the first law of motion. That means if external force is 0, then the object will be at its rest or will continue to be in its uniform motion. So, this is how we can understand the first law of motion and the second law of motion. So, dear students, I hope you are clear about the first law and second law of motion. So, let us solve few more questions from this chapter whatever we have studied. So, let us look at the question. A goalkeeper in a game of football pulls his hands backward after holding the ball short at the goal. This enables the goalkeeper to option 1 exert large force on the ball, reduces the force exerted by the ball on hands, increase the rate of change of momentum, decrease the rate of change of momentum. So, here what we will observe, that when the goalkeeper will pull back his hand, in that case it will give more time to bring down the velocity of the ball to 0. That means if more time is taking to bring that ball into rest, that means final velocity to 0, then the rate of change of momentum will be less. At the rate of change of momentum will be less, the impact on the hand will be less, as the force exerted will be also less. So, in that case we can say the goalkeeper moves his hand backward because it reduces the force exerted by the ball on hand. Similarly, if you know, if an athlete is taking high jump, during high jump, either the athlete is allowed to fall on a bed of sand or a cushion. Why is it so? Because when the athlete will fall on a bed of sand or your cushion, that will go backward little down. So, going little down will help, a more time will be to bring down the velocity to 0. As more time will be there to bring down the velocity to 0, the rate of change of momentum will be less and the force exerted on that body of the athlete will also be less. What will happen? Suppose in a game of cricket, if you want to catch a ball, if you hold that ball immediately, if you want to stop that ball immediately, it will hurt your palm. Why is it so? Because if you immediately hold that ball, the time period during the change of the velocity will be very less. As time period is less, rate of change of momentum, the value of rate of change of momentum will be much more, and because of which the force will be greater, so the impact will be much larger. So, that is why whenever stopping a cricket ball or a football, while catching that ball, the goalkeeper or the fielder, they pull their hand backward. So, that will reduce the impact of the force. Now, let us go for another question. What is the momentum of an object of mass m moving with a velocity of v? I repeat the question. What is the momentum of an object of mass m moving with a velocity v? It's very easy. As we know, momentum is defined as the product of mass of the object and velocity of that object. So, out of these 4 options, option D will be the correct answer, that is mv. So, dear students, we will conclude this topic today here. Next class we will continue with the third law of motion. Till then, go through your NCERT textbook, try to solve some more numericals on second law of motion. So that will help you to understand and learn the chapter in a better way. Till then, take care. Thank you.